Welcome, class. Today we're going to talk about Topic 2.5, absolute value functions and graphs, and also Topic 2.6, horizontal and vertical translations. All right, absolute value functions and graphs. An absolute value function is always written in the form fx equals mx plus b inside the absolute value bars plus some constant outside the absolute value bars, where your m value can never be equal to 0. Otherwise, you don't have an absolute value function. All absolute value graphs look like a V. Where the vertex is the formula negative b over m comma c. So if I asked you to find the vertex in this particular graph, you would simply say the vertex is negative b divided by m comma c, and we look for the b value, and remember the b value is this value. The m value is this value, and the c value is this value. So your vertex is negative 2 over 3 comma 6. And of course we can simplify a negative 2. That's simply positive 2 over 3 comma 6. And this would be your vertex. All right, so if I were to ask you to graph an absolute value function, the first thing I'd like you to do is find that vertex. In this case, our b is 12, so we would say negative 12, our m is 3 over 3, comma. Well, what is our c? C should be here, but it's not there, so what do we put for c? 0. And of course, we can reduce negative 12 over 3 to negative 4, comma 0. And so if you notice, I put that value in my XY table. Now when you build an XY table, I expect you to build it with some values on one side of the vertex and some values on the other side. In other words, if you have a vertex value of negative 4, make sure you pick some numbers below that and some numbers above that. So when you plug negative 6 in for x up here, you're going to get the absolute value of 3 times negative 6 plus 12, and that's the absolute value of negative 18 plus 12, or the absolute value of negative 6, and you know the absolute value of a negative number is a positive number. We've already done the vertex. Let's plug in negative 3. 3 times negative 3 plus 12, and that gives us negative 9 plus 12, or the absolute value of 3, which is 3. And so you have a 3. And now if you do the negative 2, you would plug it in and get 3 times negative 2, which is negative 6, plus 12, which is positive 6, and the absolute value is 6. So when I graph these points, I'd like to start with my vertex. My vertex is at negative 4, 0. So if I started the origin and went back 2, 4, this would be my vertex. Now, if I went to this point and did negative 6, 6, I would say, well, this could be the negative 6, and then this is 2, 4, 6. So negative 6, 6 is at this point. Negative 3, 3, somewhere about here and about here, and negative 2, 6. If I go back 2 and up 6, that would be this point. And of course, you can connect all of your points as long as you don't go through the vertex. Remember not to go beyond the vertex, because these points are not on the absolute value graph. Only everything above the vertex or below the vertex, depending on how the V sits. All right, so I'd like you to graph this equation. First, find your vertex, negative b over m comma c, negative 5 over 2 comma 0. Again, there's no c, so you're going to get a positive 5 halves 0. And if that's our vertex, I want you to pick some numbers below it and above it. So I always like to pick 0. I always like to have an origin point. So if I said 2 times 0, that's 0. Minus 5 is negative 5, and the absolute value of negative 5 is positive 5. And now I'll pick another point on this side of 5 halves. Actually, that's not above 5 halves. Let's pick a 3 and a 4. Okay, 2 times 3 is 6. 6 minus 5 is 1. The absolute value of 1 is 1. 2 times 4 is 8. 8 minus 5 is 3. The absolute value of 3 is 3. So, start with your vertex. Remember, your points always go from the vertex outward. And if we were to graph that, we would say, let's see, I go back up 5 halves, so that's 2 halves, 4 halves, this is 5 halves, and I'm on the x-axis. So that's my vertex. Now, 0, 5 is at the origin, and up 5, 3, 1. This is 3, this is 1, 4, 3, this is 4, 1, 2, 3. And you notice I did not go below the vertex. Okay, so that graph is complete. Now what I want you to do is go to your calculators. I'm going to show you how you can do these in a calculator, but remember, you need to know how to do the table of values as well. So we're going to plot this first one. We're going to plot y equals negative absolute value of 3x plus 4, close bars, plus 6, and see what that looks like. You're going to go to your equation editor, your y equals, and you're going to type it exactly you see it. Negative sign first. Remember, to get absolute values, you hit the math, number, and hit enter for 1. You should be inside your bars. And then you're going to type a 3x plus 4. And to get outside the bars, you must hit the arrow to the right key. Now you're outside the bars, so now you may say plus 6. Don't put this plus 6 in the bars because it would be different. And if we graph it, let me turn my stat plot off. Okay, you get a graph like this. All right, now I want you to go back and type in, for your second equation, negative absolute value of negative x, close bars, plus 5. And I've got that one already typed in, so I'm just going to turn my graph on. And when you're done, check to see if you got this. And now for the third equation, you're going to type 3 minus the absolute value of x over 2. I have already typed that in, so I'm just going to turn the equation on. And you should get this. Okay? Now your substitute has a worksheet for you to fill in. It will look like this, but you will get to write on your own page. Please do these in class and then answer these questions based on what your graphs look like. You should be able to plot each of the graphs on the 10 provided grids. Please do that now, and when you're done, turn them in.